So, as just mentioned, I work for NC State University. I'm a PhD student there. But the reason actually why I was hired at NC State is to work with the National Park Service, specifically the Rivers, Trails, and Conservation Assistance Program. And really what I wanted to present to you today is a kind of modular program that can be used with any federal agency in order to turn flat file data into a Web GIS interactive application. So really this is future looking, but at the moment I want to go back into the past and talk about the history of Web GIS. So we all kind of know the history of GIS. We're all geospatial analysts here. But what about the history of Web GIS? I would hazard to guess that it's not sort of as well known as GIS is. So of course we all know 1965, the Harvard Laboratory for Computer Graphics and Spatial Analysts was formed, from which both Esri and the Intergraph Corporation emerged from. Now they did a lot of interesting work, and specifically they did a lot of things with non-web-based maps. I'm going to get into that in a second, but not until the World Wide Web was created by Tim Brenners in 1990 did we move towards web mapping applications. Now, Xerox, actually, the Xerox Corporation, they created what is considered the first web map, which was called the PARC map viewer, and I'm going to show you that in a second. MapQuest. So there's some people, we've all lived through these things, but it's going to be fun to go back and sort of rehash these experiences because technology shapes our lived experience, and our lived experience shapes technology. And I would argue that it's equally a real of experience interacting with this technology as it is interacting with what we call reality. It's sort of the same thing. But regardless, the first GPS-enabled phone, not a smartphone, just cell phone, was created in Finland in 1999. We had ArcGIS in 2000, GeoServer with the Open Geospatial Consortium in 2004, Google Maps, the iPhone, ArcGIS Viewer for Flex, and so these are just they're semi-arbitrary, but they're sort of touchstones for where we are now. ArcGIS Pro, I would argue, represents the complete and full contemporary viewpoint for web mapping applications. All right, so let's just go into a few of these real quick. The SciMap that emerged in the 70s. So I just want to give you a quick anecdote here. It's kind of interesting. Nick Chrisman writes in his book that this was a crude representation of some of the first computerized printed maps that emerged from this Harvard Spatial Analysis Center. And interestingly, I'm just going to read a direct quote from Nick Chrisman here. Digitizing was pretty crude. Since a high degree of resolution was not required for the line printer display, SciMap presumed that any of the computer centers had a line printer, they all had a line printer. Each line was printed by 130 parallel slugs hitting the paper through a carbon ribbon. All slugs were the same width and height, making 10 centimeters, characters per inch. The 130 character long line led to the world's only 13-inch ruler. So the SciMap ruler, distributed with each correspondence course package. So there you have it. This was the origin. We are part of the origin of the first 13-inch ruler, and the only one, I would imagine. But so this was actually the first web mapping application in existence. The Xerox PARC map viewer. It looks pretty primitive, but as you can imagine, you could query, display, and view all sorts of geographic information. This was sort of an industry-focused web mapping application. It wasn't available to the public, but it was served up online. The Alexandria Digital Library Project and Tiger sort of emerged around 1995. You see some primitive web maps here, but at the same time, there was query and display as well as information that you could download from these sources. You see here, we have the Netscape Tiger Map Server browser. So this was federally funded, and that's the point, is we're thinking about web maps and federal applications here, and this was a confluence of both of those ideas right here. So MapQuest, we all use MapQuest, but MapQuest was important because it was the first commercially distributed routing service, right? That we all sort of used, not on our phones, but we'd print these directions out and then take them with us on the road. And then like your dad would like be fumbling through them like with coffee in his hand. It was a little strange, but okay. So here's the first actually GPS enabled phone. You see it actually has a GPS plugin right there at the top. And I just want to read you one quick advertising bit about this GPS phone. So this company introduced a revolutionary new wireless instrument one never gets lost with, featuring electronic maps, a GPS navigator, and a personal organizer, and an advanced dual GSM phone. This phone, the Benafon-esque personal navigation phone, is a complete survival pack of the contemporary nomad. And it is extremely small and weighs only 150 grams. So that's sort of how things were being pitched GPS-wise back in the 1999 era. We had ArcIMS, Google Maps, smartphone navigation that's supplanted GPS devices, and ArcGIS Viewer for Flex, which I'm sure you've all used. And I'm mostly going to talk about Web AppBuilder for ArcGIS. But that's sort of the history of web mapping applications in general. So let's move on to Web GIS Services. I think we all know what they are, but the National Park Service in particular, they've used maps for years for surveys, preservations, conservation planning, tourism, search and rescue, and facilities management. And now all of those functions are going from paper-based maps that you'd print out on one of those older technologies that I just showed you into a Web GIS environment. And that's what I'm helping to do. And that's what I want to show you as a module that can be used for other federal agencies. So you see right here, you have the GIS and the web coming together to harness the web and the power of GIS. So it's going beyond mapping and visualization. So this feels obligatory since we all know, but I'm just going to outline this real quick. The key concept of what Web GIS is that all members of an organization can easily access geographic information within a collaborative environment. So obviously distributed computing, and the server has a URL. The client relies on HTTP specifications, and all of these things that we're familiar with, basically the internet. Right, that's sort of what defines WebGIS is accessible simultaneously, asynchronously, and it exists on multiple devices. So naturally, the benefits you could ascertain would be that the global base, the user base is global, the platforms are multiple, the cost is low, it is intuitive, updates are united, and the applications are legion. We just have another Esri diagram here. Does anyone work for Esri here, by the way? These are fantastic diagrams. These are all, you can find them on Esri websites, but I wanted to use them for these presentations because I've mostly leveraged Esri technology in this project. Okay, so US federal agencies have used WebGIS applications in the past, including USGS, NIST, and the US Forest Service. People are already using web mapping services, but they're not necessarily using them in a way that's replicatable. So I'm a scientist, I'm a PhD student, so I'm interested in replicatable processes and methodologies which you can serve up and have your friends and colleagues reproduce. So even though all of these web applications have been produced, they haven't been synthesized into a single workflow, and that's what I'm working to do. Okay, so I worked specifically, as I mentioned, with the National Park Service, and it's called the RTCA program, which stands for Rivers, Trails, and Conservation Assistance Program. And it funds people to do things like this, to canoe. So just to give you a background for the RTCA, they partner. So essentially what the RTCA does is there's there's federal funds, which then are pushed out to community groups, nonprofits, tribes, and state and local governments. And they're in order to help people. Those funds help people at socioeconomic levels who don't necessarily access parks on the regular. So basically, not your REI set, but mostly your set of people who don't usually go to parks. And that's what the RTCA does: is they work to reach out to those groups and bring them to these universal resources. So. Just so you know, there is a theory backing this process, and it's Mike Goodchild, who we all know and love from UC Santa Barbara. He's a professor emeritus, and he just sort of broke down the history of GIS and mapping into three phases: the historical phase, the enlightened phase, and the contemporary phase. And in Mike Goodchild's assessment, pre-19th century GIS was created for a single purpose and not distributed to the general public, mostly for kings, etc. In the enlightened phase, global powers recognized the military value of mapping the Earth's surface and organizing information in central federal repository. So obviously Britain leveraged that to great success on their part. And in the contemporary phase that we're in now, a rapid reduction in costs associated with producing geographic information brought about by advances in and adoption of information and communication technology. So I just wanted to present that there is a theory behind this process. And so the motivation, given that a lot of these federal agencies, by Goodchild's assessment, are locked into these Enlightenment phase beliefs, we want to bring them up the pyramid into what's called a needs assessment, where we can break out into that contemporary rapid reduction in costs phase, in which it's modularized, it's reproducible, and it's extensible. So a needs assessment took place with the RTCA, and we worked with them to see what their needs were and how we can meet those needs. And so I would be considered both sort of an expert in geomatics, but also with Bill Slocum, who's also at this conference. The end user would be the RTCA, and the domain expert would be professors who worked on this project. And we enlist their specifications and then map them over data, models, and to GIS. So essentially, this becomes a platform as a service. And I'm just going to move quickly through these slides so we get to the presentation. We use all of the technologies you're familiar with: SQL Server, Excel, our catalog. This is essentially what I mean when I talk about a flat file database. Is something within SQL Server, right? So if you have a database and you have one database operator who's working in SQL, we can do better, is what I'm trying to say. And we can do better by taking the spatial coordinates and making a Web GIS application. So it goes from this to a data model, which you create and you see what attributes you want in it, to rapid deployment, to visualization. That's sort of the workflow. And I had to move through that fast because I just want to get to the demo real quick. So let's move to the demo. So I'm going to have to end the slideshow quickly and move to my web browser. All right, and then I have to move this over here so we can all see. And we are in business here. So I used ArcGIS Online, right? And ArcGIS Online provides you with the opportunity to create a public gallery. And you can see here, this is what NPS staff are allowed to see. This is what they interact with. They're able to access either the data entry form, the GIS interface, or the milestone manager and project editor. I'm just going to go through each of those really quickly so we can see what each does. The data entry form in particular is what most staff interact with. So, you know, if you work for a federal agency, you're filling out a lot of forms. And those forms may or may not be something that respond to your needs. Well, this form in particular is not only restricted by domains, which allows for easy data entry, where you can just select something that we've already predetermined you can select. And then you get feedback if you've done it correctly or not. So for instance, if I say like, you know, if I enter a project name, it lights up in green, and that's a good thing. So, but you can scroll down, you fill out all the fields, and at the bottom, I don't know if you've seen this before, it's called ArcGIS GeoForm. At the bottom, you cite your project within the United States context, and you actually place a dot on the map. And that's the key contribution here. This is actually, I would say, almost revolutionary, because you're filling out a form, you're placing that project that you're working on where federal funds are being distributed to onto a point on the map. And so you can just place that. And obviously, it wouldn't be in Canada, but this is a test project. So it looks like that. And all of that information is then compressed and then associated with that point. So moving on to where you're able to view and analyze that information is called the GIS interface. And this is ArcGIS Web Map Builder. Okay, and there's lots of different functionality. But if you look here, this is actually a live application, and we're touching the live demo, live data here. So for instance, I can just look, filter by year in 2017. And these are all the projects that have been entered by NPS staff in 2017 since this has been created. And you can see here, if I just click on a project, obviously we know all of this information is available. But this is like real data, and we have dozens of people entering it. You can even view it in the attribute table. I think we saw that in your presentation as well. The attribute table pops up, and it can be printed out as a CSV. So again, if you're not technologically savvy, you can print this out and look at it in Excel, but the information remains the same. Now, So the one key aspect of this entire project revolved around what's called related tables, because we have this project milestone table. I'm just going to go through this real quick. I see we're running low on time, but one of the key contributions to this project is being able to update these projects with milestones. So let's say, you reach a milestone that says you want to like plan outdoor recreation, and you want to measure if the launch of the river access plan has been completed or not. Well, with that, you can associate that record with that point using related records. And the developers at Esri have created a system in which that is accessible via all these applications when it didn't used to be. So what I'm trying to say is, like, think about the alternative. You'd have to create a new point that overlaps previous points, and it's really boring. You have spatial misalignment. But now with milestones, you can associate different updates with those same points. Okay, and then finally, as I mentioned, those milestones, they're managed within a separate application because they're so important. And this is our milestone manager application. You see here, if I just click on a particular project, it zooms right to the project. That doesn't actually have any milestones. But if it did, you could see the milestones that are associated with that project. But more importantly, you see how fast it zooms, and you can keep tabs. Essentially, it's a better way to keep tabs on all these projects. And this is actually only accessible at the moment between myself, who's a developer, and Peter Bonsall, who's my NPS contact at RTCA. So what I'm going to get into in the last part of this talk is how we monitor this information, because this is being input by people I've never met and who Peter Bonsall very rarely has contact with. But this is, as you can imagine, this can be used in multiple contexts outside of a park service context, right? Because if you have military bases, for instance, or different municipal parks around the nation, and you wanted to update and put those into a geodatabase, you could use the same sort of system to visualize that and then have your employees be able to access that information online. So if you have attachments, they also show up here. You see, here's an attachment, and we have what looks like an image. Okay, that's great. So let's go back to my presentation just to finish up here. Great. So the way this is monitored is with GeoEvent Server, and I would highly recommend that anybody who is interested in live Web GIS applications, check out GeoServer. Ashley Newby, who's here, is a primary contact for myself for GeoEvent. She's right back there. And it is a beautiful, amazing application because it continually monitors and what's called polling. It polls your feature services and then tells you if there are updates to those feature services. And it's essentially a stream of information. And basically, I and Peter get emails whenever new projects are put into the system or updates are made to those projects. And in the future, so I'm working on my PhD. I have some future research. Basically, I'm looking at being able to estimate and predict park visitation using social media data, specifically Panoramio data sets. That's going to involve spatial Bayesian modeling and basically doing all that in our statistical computing programming, excuse me. But that's not for this presentation. I just want to acknowledge the Park Service, NC State, Esri, and the RTCA, and I'm happy to take any questions. The question is this going to be served to the public, or is this just for better data access within federal agencies? And I would say that the answer is that it is at the moment specifically for federal agencies, because what the public could gain from this would just be visual. They'd be able to visualize these projects, but we don't want them updating and editing these projects. We want this data to be basically prevented from having access by authentication measures. So there are means in which you'd want to distribute this information, and that's what the viewer would be for. But at the moment, I'm just using the web app builder, which is designed to be interactive. And I just want to show off one thing in the web app builder, if I may. How much time do I have left here? 10 minutes, great. So if I scroll over here and close this. So one of the great things about the GIS interface is you can overlay data, and you can look at the socioeconomic status of a lot of these projects and the areas around these projects. So we do that with what are called Esri's living layers. And you see here, I just opened this layer list, and I can, for instance, overlay 2016 median age. And that will show up at the moment at the state level. But if I were to zoom in, for instance, to California, let's say, and we can take a look at the zip code and the census block level of median age surrounding these projects. So you can get a comprehensive description of an overview of what the social demographics of the people that are surrounding these projects are. And you see, you click on these individual plots, and you can see the median age of the population here is 36. The U.S. median age is 38. So that is some super useful data. As you see, if I'm going to go back to this layer list, there's not only median age, but population density, median household income, average household income, average household size. If anyone wants to see any of these, I'll be happy to click on them for California or NC State or wherever they live. But that is certainly one of the best things about this web mapping application. Absolutely. Let's move this. So it looks like we have a lot of population growth in Nevada, Utah, around Austin, and let's see how North Carolina is doing. Around Raleigh, lots of population growth around Raleigh. Not so much in my home state of Michigan, unfortunately. Actually, population decline, but that's to be expected. Yeah. Okay, so while we're demoing this, let's take a look at another feature. These are queries that have been requested by the NPS. And you can see primary strategic goal. We can sort of query by that. And this is all sort of built into the functionality. You can also do different sort of geoprocessing analyses. And those rely on pre-built Web GIS Esri function. It's going to take a while to load, but there are a few different options here. So you can aggregate points, choose best facilities, create buffers, et cetera. And that creates a new layer, essentially, that you can derive new info from. So the point is, again, so the modularization of this process. I can, again, foresee not just our TCA projects here, but let's say, well, it doesn't even have to be federal. What if it were water parks in the United States, and different water park operators wanted to see what sorts of people were visiting these and where they were distributed throughout the United States. Drive new locations. So the enriched layer allows you to sort of see the same sort of information. And you can see here, allows you to get facts about the people, places, and businesses that surround your data locations.
Another question. So the point that added, once the project is already exists, in other words, it's not about considering whether we're going to give funding to the project, but once it's there. And have you had any trouble with people actually maintaining the data? That always seems to be an issue.
That's a great question. So there are two-part question. The first is if people can, I'm sorry. Right. If they're using it only for existing projects, and essentially that is the case. We are only using it for projects that have already been authorized because we want to track the funds and how they're distributed. And without authorization, we won't be able to input these projects into the database. Second question is if there was any problems with managing this data. And at the moment, there's not. However, I've been running this on NC State servers. Eventually, we're going to have to port this over to NPS servers, and that will cause a problem because there's going to be a whole porting process, and they don't necessarily have the resources available to host this that NC State does. So that is certainly something that has to be considered within this modularization. And I think we're all set. So thank you so much.